Okay, so question 2 here, we've got pulley system here, right? And you'd think if this was released, it would accelerate this way, yeah? So object B would pull down object A. However, reading the question, it says a force, magnitude 75 newtons, is then applied to A in the direction PA. So PA is like going that way, isn't it? Okay, from P to A, that direction. So the force is almost as if it's being pushed, okay, or pulled. It doesn't really matter, okay? Easier to think of it as being pulled that way, okay, or pushed, but it's 75 newtons. And now we know it's going to be moving to the left, okay, and object B then is going to be raised. So we put our acceleration in here, okay, we can then use Newton's second law, direction of motion. The acceleration is going to be the same throughout, okay, because the string is inextensible, doesn't stretch, and this pulley is smooth, so the tension is going to be the same throughout. So let's get all the forces on there then, okay. So at A, let's resolve. Well, you've got 75 pulling it to the left. Take away then the tension in that string, which is holding it back, and that will equal to then the mass, which is 3 times the acceleration. At B then, well, tension is pulling it up, okay, and then you've got take away 5g equals to then the mass of it times acceleration. Okay, now these are 1 and 2, and you can solve them simultaneously, always adding them, okay. If you add them, the t's will go. So you got 75 then, and then add that 5g, so it's negative 5g, so 9.8 there, and that becomes 8a, okay. So when you work that out then, okay, you get 26 is equal to 8a there, and then to get a, you just do 26 divided by 8, okay, so my calculator comes out to be 3.25 meters per second squared, okay. Sub it back in then to any one of these equations, you know, you can sub it into 1 if you want, so you've got 75, take away t is equal to 3 times 3.25, that's what the acceleration is. So 75 take away t is 9.75, and then to get t, you just take the 9.75 over, swap them if you want, yeah, swap them, and then you get answer to be t to be 65.25 newtons, okay. So there's your acceleration, and there's your tension in the string.